Hey there, hope you're having a wonderful day. So in the previous two videos, we went over operator overloading for arithmetic operators and comparison operators. In this video, we're going to continue the topic of operator overloading and extend it to type conversion. So currently we have this fraction class, and if I expand this, you can see a fraction is a numerator and denominator. So we have two data members, numerator and denominator. We have our constructor, our setter and getter for numerator, setter and getter for denominator, and we have a print fraction method to display the fraction. Alright, so over here we've created a fraction object which has numerator 151 and denominator 15. So if we call print fraction and save and run a program, you can see we get 151 over 15. So just as a recap, operator overloading is a form of polymorphism, and it provides functionalities with operators instead of method calls. And if you haven't seen the previous videos, I definitely recommend you check them out first, since we introduce the concept and we go over arithmetic operators and comparison operators. So for this video, we're going to overload the conversion operators, specifically converting this fraction object into the primitive types. And for the primitive types, we have int, double, float, bool, and char, or char. And these 5 primitive types can be converted between each other. So you can convert an integer to a double, float, boolean, or character. Since fraction is a number, we can convert the number to an int, double, float, even a bool. So over here, I'm going to add a new method. And unlike the previous operators that we overloaded, for example, the plus operator, you would specify a return type and you would type in operator plus. In the case of the conversion operators, you just need to type in operator and the type. So in this case, I'm going to convert fraction to an integer. And that is because it is implied that you will be returning an integer. Therefore, we don't need to specify directly the return type. So we're going to convert the fraction to an integer. And how do we convert a fraction to an integer? Well, we just need to evaluate the fraction. So I'm going to return numerator divided by denominator. And do note here, we are dividing two integers, and when you divide two integers, you are doing integer division. So an integer divided by an integer will return an integer. So 151 divided by 15 will give us 10 point something, but since it needs to be converted to an integer, it will give us 10. Alright, so let's scroll down over here, and to test this, I'm going to do cout, and I'm going to explicitly convert the fraction. So this is also known as typecasting. So I'm going to do int of frac1. And now if I save and run the program, you can see when we convert this fraction to an integer, we get 10, which is a whole number. Now, what if I want to convert this fraction object to a double? So I'm going to copy this, paste it over here, and change this to double. Now, will this compile and run? Let's save and run the program. And here you can see when we convert the fraction to a double, we get 10, which is an integer. And the reason why this worked, despite us not overloading the operator to convert the fraction to a double, is because, as I mentioned earlier, primitive types can be converted between each other. So if we don't have the operator overloaded for converting to a double, C++ is going to look for any alternatives, and in this case, we have this operator, okay? Now let's actually overload the operator to convert the fraction to a double. So I'm just going to copy this, paste it over here, and change this to double. Alright, now if I save and run the program, you can see we still get 10. And why is that? Well, as I mentioned earlier, we are doing integer division here. Numerator and denominator are both integers. So when you divide an integer with another integer, you get back an integer. So if I want to return an actual double value, I'm going to cast numerator to a double. And it doesn't really matter which one you typecast. You can typecast the denominator as well to double. So here you can see I typecast numerator to double. And now if I save and run the program, you can see converting the fraction to a double now gives us an actual double value. And I can convert this to a float as well. So the difference between a float and double is the number of decimal places you have. So a floating point number would have roughly 7 decimal places for the float, and a double will have roughly twice as much, so 15 decimal places. So I'm just going to copy this, paste it over here, change this to float, and typecast this to float. And let's scroll down, let's copy this, paste it here, and change this to float. Alright, now let's save and run the program. And here you can see the result of converting the fraction to a float is the same as converting it to a double. Since there's not enough decimal places, you only have 4, you won't notice a difference. And of course, we can convert the fraction to a Boolean as well. So over here, I'm going to do operator bool. And how do we convert a fraction to a Boolean? Well, if you remember, for numbers, if you have a 0 for integer, double, or float, that evaluates to false. Any non-zero number evaluates to true, even if the number is negative. So here, I'm just going to directly compare numerator and check to see if this is not equal to 0. If it's not equal to 0, we get true. If it's equal to 0, we get false. So over here, let's copy this, paste it here, and change this to a bool. All right, now let's save and run the program. And you can see we get 1 because numerator is not equal to 0, and therefore the fraction is not 0. And if it's not 0, the bool will evaluate to true. And I can change this to negative. So if I save and run the program, you can see we still get 1 for true. And if I change this to 0 and save and run the program, you can see we now get 0 for false. All right, so I'm going to change this back to 151. So this is for explicit type conversion or typecasting, where we are directly changing the type of fraction to a primitive type. We can also do implicit type conversions. So one example of an implicit type conversion is if I were to create an int num1 and I assign it frac1. Now, normally this will not work because you are trying to assign a fraction to an integer. But the reason why this will work is because when you assign fraction to an integer, the type does not match, and therefore C++ will try to convert the fraction to an integer to assign to this variable. So here I can do cout num1, and if I save and run the program, you can see we convert the fraction to an int, which is 10, and we assign this value to num1. Now, what happens if I don't have the conversion operator for integer overloaded? So over here, I'm going to comment this out. And if I scroll back down and save and run the program, you can see the code compiles just fine. In this case, we get 1 for the integer. Why is that? Well, as I mentioned earlier, the primitive types can be converted between each other. So what is 1 here? It's not double or float, but rather it is a bool. So since we don't have the operator overloaded for integer, since we commented it out, C++ is going to look for the next best option, and that is calling the bool operator, which converts the fraction to bool, which is true, which is then converted to an integer, which is 1. Alright, so that's one example of implicit type conversion when you are assigning a variable a value. Now let's uncomment the operator. So over here, I'm going to uncomment this. Now let's go over another example. Another example would be implicitly converting the fraction to a Boolean for use in a conditional statement. So here I can do if frac1, I'm going to print out not equal to 0, else equal to 0. Alright, so now if I save and run the program, you can see we get not equal to 0. So we convert the fraction to a Boolean, and since the fraction numerator is not 0, it's going to return true when we convert it to Boolean. And if I change this to 0 and I save and run the program, you can see the Boolean will be false. So it will trigger the code in the else block. Now here's a question. What will happen if I remove the operator for bool? So let's scroll up, and over here, I'm just going to comment this out. Now if I scroll back down, you can see we get some errors. And if I hover over this, you can see we have more than one conversion function from fraction to bool. So we have some ambiguity here. Unlike with this integer before, where we didn't overload the int operator, C++ decided to use the bool operator as the next best option. In the case of bool, if we don't have the bool operator overloaded, then C++ will not know which one to use since we can use int, double, or float. All three of these are viable options. Therefore, if you are overloading the type conversion operators for primitive types, you should not rely on implicit type conversion, and instead, you should always overload the operator for the type that you want to convert to, okay? So over here, I'm just going to uncomment this, and if I scroll back down, you can see the error goes away, all right? Now, I want to cover one last thing, and that is implicit type conversion with other operators. So let's say I want to add an integer with a fraction. So here I can do frac1 plus, let's say, 15. what will happen? Well, if I hover over this, you can see we get the same issue, and that is, since frac1 and 15 are not compatible, they are different types, and we don't have the operator overloaded for addition, for fraction, to accept integers, C++ is going to try and convert fraction into integer instead. And to convert frac1 to an integer, you can see we have multiple options. So to bypass this, we can directly change frac1 by using typecasting. So here I can say int frac1 plus 15, and now you can see we've gotten rid of the ambiguity. So now if I save and run the program, you can see we get 15, and that is because numerator is 0. And if I go back and change this to 151, and I save and run the program, you can see the result is now 25. Alright, so that's how you can overload the operator for type conversion to primitive data types. Now, I did not overload the operator to convert the fraction to a character, and that is because it wouldn't make sense for me to do so. While you could convert integers and doubles, floats and bools to characters, it would not be intuitive to do so with a fraction, and therefore I'm not going to implement that. But yeah, that's it for this video. Hopefully you found this video helpful, and if you did, make sure you give this video a like. If you have any questions, let me know down below in the comments. And as always, if you want to stay up to date for more C++ tutorials like this one, make sure you subscribe to the channel, and I'll see you in the next video. Bye bye.